Welcome. This is Panda Consulting's ArcGIS workshop, and I'm Frank Conkling. And for this workshop, we're going to continue on the introduction to Arcade that we did last workshop meeting at the end of or the beginning of December. And we're going to look at sort of conditionals. Now, this is not a real programming course or anything, but I just want to go and introduce you to some of the different variations on that. Before we start, let's go over a couple things real quickly, just sort of who we are. If you're interested in Panda Consulting, what we do, how we came about, what the services we offer, please go and visit our website. There's a QR code on top of the page right here. You can go there, find out about us. There's also an events calendar that you can look at. If you'd like it, there's also events workshops, listings, and you can see not just the ones coming up and where we're going to be as far as conferences, but you can actually download recordings of the previous workshops. And that's all also appears on our YouTube page. Please go out to YouTube and look for Panda Consulting, and hopefully you'll find some components on there that are interesting to you. I think we do have like 75 different YouTube videos out there now, and hopefully it's we're going to start updating our website to go and illustrate how you can use some of these videos just for free training for you. So look for that also on our website, on our blog. Before we start, let's also, for those people that are in attendance here, and by the way, thank you for attending, and it really helps us to fill this out a little bit more. Chris with Panda is actually moderating, and he's going to be watching the chat window. And he's going to, please put any comments or any questions up there, and he will go and pass them on to me. He knows now that I can keep talking, and I'll keep talking until somebody interrupts me or has me be quiet for a while. So, all right, let's start. So just sort of a quick preview of our previous workshop. We talked about what Arcade is. It's a portable, lightweight, and a secure expression language. It's a language for doing and creating expressions that are used inside of ArcGIS. Now, those expressions can do things like mathematical calculations, format text, evaluate logical statements and such. And you can have multiple statement expressions and variables and flow control. And a lot of that was introduced last time. This time, we're going to go and look a little bit more about evaluating logical statements. And this is what I refer to as being conditional. You look at the conditions of the data, and you'll have the Arcade do one thing or the other, and we'll go from there. All right. This is not a programming workshop. This is mostly just to demonstrate sort of how to use some of these tools that are inside of Arcade. There are some good programming workshops out there that you might look at, and Esri has some that I think are worthwhile. But hopefully this helps move us along a little bit more. All right. First thing you want to do is just please go out to the Arcade reference. It's got a really good help files now. In here, in which they have all statements, comments, variables, functions, loops, and logical statements. It goes through. It's a really good setup. Esri did a great job with this. That they've rewritten all of their help file for it, and it's really nice. It's a good reference for you. So let's go and look and see what some of these things are and how you can use them. And let's start with one in which, and we said that Arcade can be used a couple different ways. It can be used for labeling. It could be used for calculating fields. It can be used in attribute rules. It could be used in pop-ups. It can be used in all across Esri's technology stack, ArcGIS Online and ArcGIS Pro. You can use it all over the place. We're going to look at a couple different places. The first one's going to be labels. All right. And on here, if we look right now, just simplistically, if we go and say, let's go ahead and label these polygons in here, and to look at this stack of information, it's fairly simplistic. If we go and tell it, and let's go over here and look at the label functions in here. If we tell it to go ahead and label the polygons on here, you'll see that we actually have two different sets of labels. One for large parcels, which has the full parcel polygon parcel ID in it, and then it has the acreage in it, and then for one smaller ones. And standard in here is that if we go and look at this, and actually look at let's look at the labeling properties here, and look at our SQL statement, basically what we're doing is we're creating two different label classes. One that says if the shape area is greater than an acre, go and put this one in, which has the acreage in it. The other class right now is saying, well, if in fact the shapefile is less than an acre, go ahead and just put the right 3 letters in here. And this is the way we traditionally would do this in ArcMap, or the way we do it in ArcGIS Pro. But with Arcade, because we have a much richer way to go and analyze this, we can write them all in one label class without having the actual software go through this multiple times. The one time to go and display it when it's smaller, and then the second time displaying it when it's larger. No, we can do it all at one time. So let's turn this off and look at this Arcade, in which we have now. Let's go ahead and pull this up so we can explore this a little bit more. All right. And in here, see, this is very, very simple, in which what we've done is, let me make sure I got this whole thing here. Okay. Go and do it again, and here. I guess I have to go and turn it on first. So in here, I've got it set up so that it's going to go and give us the Arcade expressions in here. Now, what I haven't done in this, I haven't really got a conditional put in place. So let me go and do this again, bring it up here, go here, and actually go in and look at this. So again, what we're doing with this is we are telling it that if it's considered small, to go and just use the right. If it's considered big, go ahead and use the left. Well, we haven't set anything up here as far as the labels or anything else in here. Let's go ahead and set. Let's make sure, again, I want to make sure there's nothing here, nothing here. Yep. All right, so what I want to do is I want to go and say, well, let's see if we can figure out how we can do this. And what we're going to do is we're going to go and set a variable. So we set a variable for small, which has the label expression for small. We have a variable for big, which sets the label expression for big. And then we're setting a variable for all of these. And what we're going to do is we're going to use an expression called if. All right, and we're going to say, and it might be easier to build it in here, if in fact the feature dot shape area is less than 43,560, all right, let me go and do it this way. It's easier. I've already got it here. So we've got the variable is small, got this, we've got the variable big, we set an empty variable called label. And then on here, we set it up with this IIF. The IIF function goes and returns a value if the condition evaluates to true. So if it's true, it does the first part of it. If it's false, it does the second part of it. So what we've done in this statement is we've looked at this and said, evaluate the shape area and tell us if it's less than an acre. And if it's less than an acre, go ahead and make it small, put that as the expression in here. If it's more than an acre, go ahead and evaluate it and make it big, and then just return the actual value that's stored in label. All right, so real simple. This is probably one of the easiest conditionals that you'll do, and it's one of my favorites because all you're really doing is say, do this or do that. All right, and so it's all determined by whether or not it meets this condition, or whether, to say it properly, whether this condition returns, this evaluation returns true or false. The IIF function, again, it's one of the easiest ones to use, and it's super simple to go and implement. So I'm going to cheat a little bit here. Let's go back here. Let's take this. Copy that out. Let's go back to here. Let's go back in here. And let's return that. Let's evaluate it and let's apply it. And in fact, what we'll see is that all of those are going to turn that off, and make sure this is on here. So it does the same exact evaluation, and it's going to give us the exact same results with fewer steps, because it uses Arcade to evaluate whether or not that expression is true or false. Super simple way to go and do this, and you can expand on this however you want. For example, in here, you might say that this setting it is big. You go and use some text tags in here, make it bold, make it, however you want. So I can say that maybe if it's a small one, we include the bold tag. And then we go here. Let me go in back here. Turn off the bold tag, evaluate it, say go ahead and apply it. And now all of these are bold. So it's just, you set two conditions, you set one condition and you set two basic strings that you're going to go and return. If the condition is met, you do it one way. If it's not met, you do it the other way. Well, an interesting thing in here, one that I really like, is you can set this evaluation, this IIF, to be, well, if it's less than this, or you can set it where it's more of it. And you're going to see next, we have another condition which is called IsEmpty. If it's empty, do this versus that. So again, any questions on this? Any comments on this? Again, this is probably the simplest one that we're going to look at today, is IIF. Is the condition met? Is it true or is it false in here? All right. Again, one of my favorites on here. So once we're done with that, then there's another one that we can go, another logical condition that we can look at and saying, is this field empty? Does it return? It returns true if the provided value is null, or it's an empty text string. So in this case, we can say, we can do, for example, that the expression, the label expression, is the name and a dash and rounding it out to 2, and this, and then we can say, okay, if it's empty, if it has no value in it and it's empty, just return the name field. If it's not, they go and return this. And what we've done is I've gone in order to demo that, I did it on not a labels, but rather on an attribute rule on here. So let's go over and start looking at how you might do this on an attribute rule. So let's go to our attribute rules. And by the way, these are the attribute rules that we used last workshop. I've just sort of built upon this, just sort of to go and show you a little bit more. So in this demo here, what we have is we have on the polygons that says if the name, well, first of all, we're setting it up so that the first expression is that if the, puts a name field and a dash and an acreage after that, and then we're going and evaluating and saying, again, using IIF, that if it's empty, if the name field is empty, go ahead and return label equals feature name, meaning return the actual name of the parcel. If it's not, go ahead and return the expression that we've set here, and then we're just going to tell it to return that label. So how does that work? Well, let's go and do a create, and let's see if we can look at this a little bit more. So if we go in here and we'll set a polygon. Again, this does not have to be the parcel fabric, even though I am using a parcel fabric as a sample data set. I'm also going to go and turn off the labels here, all right, so that we don't see any labels in here, because I'm using this for calculation of the values that are in here by having a calculation performed as a result of an attribute rule. So in this time, what I'm doing, and again, let's look at this again. I'm evaluating whether or not the name field is empty. All right, whether the name field is empty. If it is empty, go ahead and just put the name in. If it's not empty, go ahead and use the expression on here. So in this case, this is the name field. And because it is empty, you're going to look at this parcel map ID here is the field that's going to get populated on here. So if I just go and put some value in there, you look and immediately it put that value that was stored there, and it went and added the dash and then the acreage with the text appended after it. So it's evaluating whether or not that field is empty. And these other valuations that are coming in are the results of those other attribute rules that we have, where it's calculating the acreage and then it's calculating the parcel number and the parcel ID on here. But this is the expression that right now is using that conditional and saying, if it's empty, go ahead and put that in. So what happens then, if we go in here and we make that empty, suddenly the values get cleared out, so that now the map ID here, this one here is the one that's getting evaluated and put in here, suddenly gets populated. So if I go and put it, a parcel in there, it goes and automatically goes and evaluates it. Again, pretty simple solution, but it's going to go and evaluate it and put it in place depending upon the condition. And it's evaluating whether or not there's any text in that one field. Again, just real closely. And it might be easier to go and see it here. So what we're doing is we're evaluating it here with this is empty. logical condition and saying, if the name field is empty, go ahead and do this. And that's the IIF. If it's not empty, do this in here. Any questions yet?
No questions so far.
No questions. Good. I'm either it's too simplistic or everybody's just sort of waiting and listening. So one of the things I'm going to do now is I'm going to use, and if I looked on here, if I looked at some of the logical here, loops, if thens here, the comparison operands, these operators here on here, we have, for example, we can compare this and say, is it equal to here? Is it equal to true or not? So is y equal to x or is x equal to y on here? Is it not equal to? And notice by putting that exclamation point in front of that evaluator, it becomes not. So is it not equal to that? Is it greater than? Is it greater than or equal to? Is it less than? Is it less than or equal to? We also have logical operators down here where we can say it's a logical or. It's either this or that, or this is logical ands, where it's this and that, or this is just a logical not if it's not that. Now, the reason I showed you that is I wanted to go and come back here now and say, well, let's turn this around. And in here, again, this is an attribute rule. So when I change and attempt to save an attribute rule, it's going to say you've got edits that aren't saved yet. Do you want to go and save them or not? I'm going to say no, delete them. I'm going to start a new one. So what I'm going to do is I'm going to go and say, well, I want to evaluate whether it's not empty. If this is not empty, then just go ahead and put the expression here, or again, I'm putting an expression there, and if it is empty, to go ahead and put the name in. So I just reverse that. And really, it just depends upon how you want to go and look at this logic as far as whether or not it works or not. I'm going to say delete my edits and then go ahead and save this attribute. So understanding those logical evaluators, is it empty? Is it not empty? You know, that will help you to understand how you go and evaluate things and calculate them using Arcade. So we're going to go and create a new parcel now. And this time, when it's empty, we'll see it should work the same way. I've just reversed the logic on here. I remember when I was out in the field surveying, we always used to use Hewlett-Packard calculators because they had reverse Polish notation. And it took a while sometimes because you sort of were evaluating things backwards, whether it was equal to this or not equal to this. And so this is, you know, whether it's empty or not empty, it's dependent upon how your logic works. So let's go back here now. Let's create another new parcel. And this should work exactly the same on here, and that there's nothing in here. But as soon as I put something in here and hit enter, it works again. So on here, again, we used IsEmpty. And we also went and showed you is empty or is not empty on here. And so we can use that, again, a lot of different ways. We could look for things that evaluate, for example, all of our attributes in a table and calculate that if there's nothing in there, go ahead and put something in there. Otherwise, just return the value that's in there now. So let me go and see if I can show you how we do something like that. Let's go to our attributes now. And let's get rid of this. Let's clear that out. So in here, we've got some parcel map IDs that are here. Well, we can take that exact same attribute rule here. We can take this exact same attribute rule. All right. And now do a calculation on this entire data set using this same rule that says, if it's empty, make it this. If it's not empty, do something else. Now, again, I'm seeing some values in here that are different. So it's just going to go and apply this on everything. So I'm overwriting some of these values, but that's all right. This is a demo data set on here. Let me stop here and see. Open up again. Do we have any questions? Do we have anybody that's actually used IIS or IIF, or have they used IsEmpty or is not empty anywhere? Do you have any comments on any of that?
Not at the moment.
Wow. All right. All right. So anyway, I'm going to go ahead and stop this only because this is much larger. We do have time in here, but since we don't have any questions, normally would have taken questions here. But I think we're fine with this. So we can be used in labels. It could be used in attribute rules. It could be used for calculations in here also. Let's stop this. All right, let's stop that. And it's the same arcade expression. We don't have to go and modify it how we use it. We can just use it anywhere where there's an expression. It's IsEmpty. All right, so again, we've been if. Again, it's either true or false, or IsEmpty, if else. So now let's look at this condition a little bit more. If else allows us to go and implement a series of expressions, a series of conditions, and then allows us to go and use those here. So right now, if we look at this, right now what we're saying is we're going to set up a variable called dimension or dim. And if the arc length is empty on here, make this variable equal to rounding the distance field equals to 2 decimal places, and then putting this value on the end of it. All right, so if we have an empty arc length, to go and do that. If, however, the arc length is not empty, go ahead and put it in as the arc length here. Excuse me, this was the distance field. This is the arc length field. So if there's something in here, go ahead and put this variable, populate this as being the arc length value. And then we're going into a second valuation that's going to say, okay, well, what about the Kogo type? Let's evaluate those. So the first one says, if the Kogo type, all right, if the Kogo type is empty, meaning there's nothing that's stored in the Kogo type, and we're going to explain what the Kogo type value is here, just go and return null. Don't do anything with this. If, however, the Kogo type is 1, and this is parcel fabric specific, to go ahead and return the dimension. If the Kogo type is equal to 2, return null, or don't store this dimension in there. And if the Kogo type is 3, store the dimension in here. So I've seen that Jeff put something up there. Use calculation attribute rules to calculate a field based on values from another field. Correct. That's usually what these are used for, Jeff. Here's an example, one I really like on the survey lines within the parcel fabric. The distance per, right. So you're evaluating whether or not the error parts per million is that. It's a good example, Jeff. Thank you. I mean, those of you that are looking at this online, you can't see that, but yeah, that's a good expression. So what we're going to do here is we're going to use this, and we're going to use this as an attribute rule to calculate whether or not it populates a dimension field, depending upon a couple of these variables. All right. So we're going to a line feature class. In this case, this is the attribute rules. And here is this same attribute rule, this same arcade expression, what it's going to go and store. And again, it's going to look to say if there is an arc length in there, if the arc length is empty, it's not a curve, all right? Store the distance field. If in fact there is an arc length in here, we're going to go and use the arc length in here. And then we're going to evaluate whether or not what type of Kogo field is being, or what type of Kogo type is on here. So let's go here to here. And let's go and navigate over to here. And we have a line here. And all we want is that line. And now that line actually has some Kogo values on there. All right. And if I go and null out this line, all right, and here's my shape length, here's my distance field, here's my arc length field on here, and here's this dimension field. That attribute rule is going to be used to populate the dimension field and tell it how to go and populate it. So a little bit of inside the ballpark here. Within ArcGIS Pro, Kogo fields are numeric values. So if I look here at my distance field, it'll tell me that this is a double precision floating point value. And here's my radius, so the same way. These are all number fields in here, the arc length. However, the Florida Department of Revenue is looking for text strings. They can't evaluate whether or not that value that's stored on the distance field is correct, because when it's returned to them, it's returned with 6 floating points. It's returned with 6 decimal points after the decimal. So they want you to give them a text string to say, what is the value that's stored on that deed or on that subdivision plat? So what we do is we evaluate whether or not there's Kogo on here. And if there is Kogo, whether it came from the Kogo type, and let's look at the values of the Kogo type. The Kogo type field tells the software, or tells the user, whether or not it was entered in there, whether it was computed, or whether it was from the geometry. All right. So if we put in here a value, it's going to get evaluated. And it's evaluated, and it depends upon whether or not this Kogo type has been set. So it's going to say, if it's null, again, let's look at this just to make sure. So it says here, if the Kogo type is set to null, if it's empty, don't do anything. All right, so if it's empty, don't do anything. But if we change that and say, no, this is here, if we note, it automatically goes and populates this field. And it does that here when it says, okay, well, what value is returned? If in fact it's returned as being a value of 1, it's going to return the value. If, however, it's returned as a value of 2, in this case, if it's returned as a value of 2, which by the way, these are not in order. If it's returned as a value in 2, it's going to remove it. It's going to null it out and put nothing in there. So if it is originally from geometry, or if it is entered, it will go and store it. But if it is null, it does not store the value, or if it is calculated or inversed, it will not store it. So again, using this evaluation, or what I consider conditional statements, how does this evaluate the attributes that are stored in certain fields? And as a result of that, it's going to go and populate them a certain way. Let's demonstrate that a little bit more, but this time what we're going to do is we're going to go and put a curve in here, all right? And we'll make this curve. All right. So that I can there. All right, so I've got a curve here. And if I look at the attributes on here, there's nothing in here, all right? Nothing in here. The Kogo type is set to nothing. If I tell it to go ahead and update the Kogo on here, I can tell it to go ahead and update this. Now I have Kogo values on here, but it's still set to a value of 2. Note the distance field has nothing in it, but the arc length field does have something in it. So if I tell it now that no, this was entered on here, what happens is it takes the attribute, the arc length attribute field, and appends, or goes and puts the record value on there at the end and stores it in that dimension field. Again, set it to null, that disappears. Set it to from geometry, it still has nothing in there, but set it to entered, it automatically goes and populates it correctly. All right, those are some of the conditions on here, which allows us to go and evaluate what's going to be stored and whether or not it's going to be stored in here. So we've actually got 2 different evaluations going on here. This first level of evaluation is whether or not there's values stored in these 2 different, in this field, and what is going to go and populate in the dimension variable. If there's something in the distance field, all right, excuse me, if there's something in the arc length field, it goes and stores the distance in here. Let me say this again. If there's nothing in the arc length, if it's not a curve, it stores the distance. If it is a curve, it goes and stores the arc length. So it's then populated the dimension variable. Now we go down and say, okay, what is the Kogo type attribute field look like? If there's nothing in here, just return null. If it's empty, there's nothing in here, don't do anything with this. Or if it's a type number 1, return whatever values are stored in this dimension variable. Or if it's a type 2, if it's equal to 2, set it to null. Or if it's equal to 3, set it to the value that's stored in the dimension. All right. So we went over if and how to evaluate that. We went over IsEmpty and evaluating that and storing it is empty or is not empty. And then we went over with a couple of ifs and elses in here and did those. All right. And this is how it works. It's invisible if it's done correctly. The problem is going and making sure that you've got it set up correctly. So just experiment with this. Doesn't going to do any harm. The one thing I would say is that set it up so that you're not changing anything immediately. So set it up as a label expression before you do anything else in here, and then just see if that works. All right. Before you go and do any calculations, because calculations will in fact make these changes on here. Okay. So let's look here. So next workshop, next month, a month from now, we're going to look at feature sets, which are not just evaluating conditions in your existing layer, but going and analyze them against other layers, other feature classes or other feature services, and then pulling values out of those feature sets and using those for populations or for labeling or anything else. To give you sort of a sneak peek on that, let's see if I can go and turn on my subdivision layer. So if I do a select here, all right, let me go in and make selections here. Let's go in here and make sure all of these are turned on, make sure they are selectable. On here, let me get out of Cocoa. All right, now let me go and do my expressions. On here, let me do a selection. All right, so in here, I now have one parcel and one subdivision polygon. What I'm going to do is I'm going to go and do a label expression real quickly to say, hey, what subdivision is this parcel located in? All right, to just demonstrate this. So in here, let's go to our labels. And mostly this is just to fill out the rest of this. SimCon. All right. So I'm going to create a SimCon expression. All right, and I'm not going to use that. Instead, what I'm going to do is I'm going to go and I'm going to cheat for this because this is a demo. And I'm going to use an intersection. Here, let's see if I could do that. All right. All right. Oh, nope, sorry. Wrong one. Hold up the wrong attribute rule. Let's see about this one. There we go. All right. So what we're going to do is we're going to go and intersect against the subdivision layer. And the way this works is that we're going to get a text string from not the tax layer, but from the subdivision. Again, this is just a comment in which we're going to do a feature set, and we're going to do the feature set by name. So we're going to have to put in here the name of this. So while we're doing that, let's go down here and cancel out of there. Let's go and look at the property here and see what this actual name is. This is subdivision underscore PF. So this is underscore PF, and we're going to get the name field out of there. And then what we're going to do is we're going to intersect the actual centroid and whether or not it found anything. This is going to be return Excuse me. This is why you always have issues doing demos on the fly, because I really wasn't going to do this initially. All right. So let's see if we can get this to work. Data store name. Yeah, I don't think I'm going to be able to do this, not within this time. So we're going to show you how to do it though. Next workshop, we're going to go and do this. All right. Any other questions? Nope. All right, we're going to go in and stop recording then and move forward. Thanks for attending, and we hope you enjoyed this workshop. If you have questions, would like some more details about anything we discussed during this workshop, or if you or anyone at your organization would like information about training, support, or ways in which we can help you with your GIS needs, please contact me at frank@pandaconsulting.com or call me at 561-691-3277, and we can discuss how we can help you with your needs.